Hello and welcome to this lecture. In this lecture, I will show you how to use ASPEN HYSYS to plot binary and ternary diagrams, right? So you'll be learning how to plot that in this particular tutorial. So going forward, let's just add components. So I have some components. We have benzene, then we have toluene, then we have I think we have water, then ethanol and acetone, then acetone. Let's say we make use of Antwine for this illustration. Just make use of Antwine for this, so we can go into the simulation environment. So in the simulation environment, there is a feature in the model palette that can help you develop binary and ternary diagrams, right? So there's a feature in the palette. It is called equilibrium, right? It is called equilibrium unit, right? So you can pick it out. Let's say I pick a couple of them so that we can work. Let's say I just pick 4, so we can plot a few diagrams, right? So if you open this, you will see the environment where you can actually make such plots. So you have the binary section and then you have the ternary section as well, right? So ternary is for a 3-component mixture, right? A 3-component mixture, while binary is for a 2-component mixture, right? So basically that's how it works. So in binary, you have the XY plots, you have the TXY plots, and you have the PXY plots, right? Then for ternary, you have the LLE, and then you have the VLE as liquid-liquid equilibrium and vapor-liquid equilibrium. So you can generate these 2 plots using the ternary option, right? So starting with the binary, for example, we could plot an XY for a mixture of let's say a mixture of benzene and toluene, right? So you click on the components, then you click add component, then you click toluene, you click add component as well, right? So you click on this, then you specify either pressure or temperature, right? Either pressure or temperature. So for example, if we specify pressure, let's say we specify pressure of 1 atm, which is atmospheric pressure. After that, you can click on plot, right? So when you click on plot, the binary plot is generated, right? The binary plot is generated based on the specification you have made, right? So this is basically what it looks like, right? This is what it looks like. You can view the table generated by the software, right? So this is the table for the XY plots based on the pressure specified, right? So this is the table. You can actually maximize to view it better, right? So you have the XY plot and the table that was used to generate the plot, right? So this is the table used to generate that plot. So you can also maximize the plot environment, right? So this is it, right? So we can also do a couple of others as well. We can also do a couple of others. we can do a TXY plot, right? A TXY plot. So for that, what you need to do is click on TXY, right? So this particular plot will give you the bubble point and dew point of the mixture at different mole fractions, right? At different mole fractions. So, but this bubble point and dew point will be with respect to temperature, right? With respect to temperature, because it is a TXY plot, So it will be with respect to temperature. So now we change it to TXY, then I can click on plot, right? So you see, when I click on plot, it generates the plot based on the pressure specified, right? So this is a TXY binary plot, right? So you can also click on view table. Mole fractions of benzene, right? The mole fractions of benzene, and you will see the bubble point, right? That is the bubble point of the mixture and the dew point of the mixture at different mole fractions of benzene, right? That's the essence of this particular feature. So you see the bubble point and the dew point at different fractions of benzene. So for example, at 0.5 mole benzene, your bubble point is 91.17, right? At 0.5 mole of benzene, your bubble point is 91.17, your dew point is 98.44, right? So basically that's how it works. So you can also do a PXY plot, right? You can also do a PXY plot, right? So let's remove this. So now you can change to PXY also, right? This is PXY, right? PXY. So PXY, we have to specify temperature. So let's say we specify 40 degrees Celsius. So 40 degrees Celsius for PXY. Then we can click on plots. Yes, and it generates the plot. Right. So this is the XY plot, and this plot will give us the bubble point and dew point values based on pressure. Right. So if you maximize this and you click on view table, you will see the table here. So at different moles of benzene, it gives us the bubble point and dew point values based on pressure, right? Based on pressure. So you have kPa, right? Because this is a PXY plot. So it is based on pressure now, right? So you are specifying temperature, and then the software calculates the pressure values at different mole fractions of benzene. So for example, at 0.5 mole of benzene in the mixture, in the benzene toluene mixture, you have 16.25 kPa for bubble point and 11.94 for dew point, right? So basically this is how it works. So yeah, so that's for the first. So I'm just trying to illustrate how it works. So for example, let's see a question. So see this question from this book, right? This is still Coulson and Richardson, volume 2, right? Coulson and Richardson volume 2. So it says, what is the dew point of an equimolar mixture of benzene and toluene, right, at 101.3, right? So I believe 101.3 is atmospheric. I believe it's atmospheric pressure, right? So it says, what is the dew point, right? Dew point, that is the dew point temperature, because it provided pressure, right? It provided the pressure value. So this question is a dew point temperature question. So we are going to be plotting a TXY plot, a TXY plot for an equimolar mixture of benzene and toluene, right? Because the pressure was specified. If temperature is specified, then you will plot a PXY plot, right? If temperature is given, you plot a PXY plot. If pressure is given, you plot a TXY plot, right? That's how it works. So after specifying the pressure, we can click on plots, right? So it generates the plot for this particular problem. It generates the plot. Then we can view table. Yeah, we can view table. That's an issue. What did I do? What did I do to the plots? Let me just specify this again. Yeah, I hope it works. Let's specify it again and then click on plot. Oh, why did I zoom? Did I zoom in or zoom out? Okay, so I clicked on reset. I clicked on reset zoom, right? So this is the plot here. So if you view the table, it says, the question said, what is the dew point of an equimolar mixture, right? An equimolar mixture means you have 0.5 benzene and 0.5 toluene, right? So benzene mole fraction is 0.5, right? So from the table, you can actually determine the dew point, right? So 0.5, this is 0.5, right? For mole fraction of benzene, right? The dew point is 98.434, right? The dew point is 98.434 degrees Celsius, right? So let's check what they actually got here. So if you check this, let me see. Okay, they got about 372 Kelvin, right? 372 Kelvin. So we can actually add that to, we can actually convert this to Kelvin, right? We can convert it to Kelvin. Let's convert it to Kelvin and see. So we have 98 plus 273, 98.434. Yeah, 98.434 plus 273. You see, so by the time you add 98.434 to 273, you will get 371.434, right? 371, where is it? 371.434 Kelvin. Yes, Kelvin. So, and that value is actually very close to what they got. They got 372 Kelvin, but the software got 371, where is it? At 98 degrees Celsius, they got 371.434 Kelvin, right? So that's the solution to that particular problem, right? So the software can actually solve some of your classroom problems, right? And this is the plot generated based on that table, right? So basically we have been able to solve that problem, right? So I had to actually remove some other components just to continue with the illustration, right? Yes. So another way to actually solve this is to use you can use a material stream to also solve that problem, right? You can use a material stream to solve that particular problem, right? Two material streams. Let's name this one, let's name this dew point. Let's name this dew point, and let's name this one bubble point, right? Bubble point, right? So now the rule is that at dew point, your vapor phase fraction will be 1, right? At dew point, your vapor phase fraction will be 1, and at bubble point, your vapor phase fraction will be 0, right? So now we can start with specifying that. So this will be 1 for dew point, and for bubble point of the mixture, vapor phase fraction is 0, right? So we can actually work with this. Now, the question said equimolar mixture, so the mole fractions will be 0.5 each, right? So 0.5, right? And then we can also do that here, 0.5, also 0.5 here, right? So we have all of this now. Then we can specify the pressure. The pressure is 101.3, right? 101.3. 101.3. That was the pressure given. Then the molar flow. The molar flow is, we can make an assumption for the molar flow, right? The assumption we can make for the molar flow is 100 kg mole per hour, right? So we can specify this as 100 kg mole per hour. Yes. So once you specify all of that, you will be able to get the values for your dew point and bubble point. Now let's compare. Now let's compare what we have for both. Now you can see the dew point temperature, right? For 0.5 mole, right? Look at it here. Dew point 98.43, right? And you can see it here also, 98.43, right? So you can also use this. You see it, 98.43, 98.43, right? At 0.5. Right? This is for dew point. Dew point. Now for bubble point, you can also compare, right? You can also compare bubble points. So bubble point, you have 0.5, 91.168, right? And you can see it here, 91.17, right? So these are ways you can actually do these things. But this equilibrium plot is better because it gives you the dew point and bubble point values at other compositions of the mixture, right? So this is not only for 0.5, it's for other compositions as well, right? Other compositions are involved, so it gives you a range and it gives you the plots, right? You may not be able to get that with the material stream, but I'm just showing you that the material stream can also work, right? So the next thing now is to plot a ternary plot, right? So that's what we are going to end this lecture with the ternary plots. So let's quickly do that. So for the ternary plots, you go to the ternary section and you either choose LLE or VLE, right? So depending on the kind of mixture you have, if you have a vapor liquid mixture, you use VLE. If you have a liquid mixture, you use LLE, right? Depending on the components that make up the mixture. So we have H2O, then we have ethanol and acetone, right? So I will just specify parameters. So for ternary plots, you have to specify both the pressure and the temperature at the same time. Right, so after that you can actually generate your plots. Yes. So basically this is the ternary plot for the H2O, ethanol and acetone mixture, right? So this is the ternary plot for that, and then you can view the table, right? You can view the table generated based on the plot, or the plot that was used to generate the table that was used to generate the plots, right? So this is it here. So basically that's how these plots work. So in this tutorial we have been able to understand how to plot binary plots, right? Also how to use the material streams to calculate dew points and bubble points, right? And then we have also seen how to generate ternary plots, right? So this is how to generate ternary plots basically. So you just have to add the three components in the mixture and specify whether it's LLE or VLE, then specify the pressure and the temperature of that particular mixture, then you can generate your plot, right? You can generate your plot. So basically that's how it works. If you have to change your parameters, then you can click on update plots, right? You can click on update plots. Let me see. So you can click on, okay, so it gives you the prompt to actually update your plots, right? So that's how it works, but I still want to use the 40 degrees in this case. So you click on plot and it generates the plot for you. So basically that's how these plots work, right? With that we have come to the end of this particular lecture. If you have questions, let me know in the comment section. Like this video, share with your friends, and then subscribe to this channel if you have not done so yet for future notifications on process modeling. Thank you for joining me in this particular lecture. Do have a good day.